For Unit 9 objectives, we are going to identify exponential functions. So you're going to look at it and say, is that an exponential function, yes or no? Right? Identification, we love that standard, that objective, because it's pretty easy. Identify exponential functions. After we identify exponential functions, we are lucky enough to get to graph exponential functions. Which again, graphing isn't going to be that big of a deal because we're going to follow step-by-step rules. And then last but not least, we are going to evaluate. Exponential functions. Technically speaking, I guess these two should be flipped. You need to evaluate before you can graph. That's how we get to the graphing. They're going to involve. What do you think they're going to have? Exponential functions. Numbers, exponents. Right? Exponential functions are going to involve exponents. So let's start by defining exponential function. Exponential function, by definition, is a function. And function is just a fancy word for what? Equation. A math problem. So it's going to be a math problem, a function, an equation, where the independent variable when we graph, right, the independent variable goes on the bottom, so like time, independent. You can't, no matter what you do in your experiment, you can't change time. I cannot make time speed up or slow down. Time is an independent variable. Your independent variable, so if your independent variable always goes on the bottom, what variable is it? X. Your independent variable, your x, is an exponent. All right, you're going to have to do a little bit of writing of word problems, but just know that your homework you don't have to because it's a worksheet. So let's look at an example of an exponential function. So f of x, function notation, equals 2 times 3x. This is exponential function. It's written in function notation, and the independent variable, the x, is an exponent. You could also rewrite it as y equals. This would be equation form. This is function notation. So this models an insect population. After X days. So this function right here models the insect population, the fruit fly population, after X number of days. What will be the population after 5 days? So this is an exponential function, and exponential functions get big fast. I want to know after 5 days, what will the insect population be? So what am I going to do? Yeah, instead of my variable of x, I'm going to put in 5. So f of x equals 2 times 3 to the 5th. Am I going to do 2 times 3 first, or am I going to do 3 to the 5th first? 3 to the 5th goes first. So, just so you can see what it looks like, 3 to the 5th is 243. So what's the insect population after 5 days? 486 what? Give me a label. Insects. So in just 5 days, the insect population would be at 486 insects. All right, so what if they give me a table and they say, is this exponential? If they give me a table or a set of ordered pairs and they say, is this an exponential function? Right, so here's a relation. And I want to know, is this relation, set of ordered pairs, is this an exponential? Does it represent an exponential function? I find it sometimes easier to look at these vertically instead of right? I like to put them as a table. It's easier for me to see. So we look for the common difference. What does it do from -0 or -1 to 0? It adds 1. What does it do from 0 to 1? Adds 1. And what does it do from 1 to 2? Adds 1. All right, so that's a constant change, correct? So let's find over here. What happens from 1 to 0? -1. What happens from 0 to 1? +1. And what happens from 1 to 4? Well, that's not a constant change, is it? But, oh, this is Molly. Huh? Yep. Okay. Corbin, you're needed for math makeup in 116. But this is exponential. 1/16. This is exponential. So do you think I should look for the addition or subtraction change? Let's look for a multiplication or division change instead. So that's what we're looking for. Your x change should be constant by multiplying or constant by dividing. Nope, just your x value. So we want the x value to be constant by multiply or divide. What? Sorry, I meant your y value. Because your x is what you do. Thank you. Your y value. So I want to look. 1 divided by 0. Or 1 times 0. 0 divided by 1. And 1 divided by 4. So are these a constant change? No. It was constant up until here, right? But then my last value does not fit the pattern. Let's try another one. Let's do... -1, 1.5. 0, 3. 1, 6. And 2, 12. So let's look. I'm going to list them. -1, 1.5, 0, 3, 1, 6, 2, 12. You try it. My numbers, let's see, from -1 to 0, I add 1. From 0 to 1, I add 1. And from 1 to 2, I add 1. That's perfect. This is a constant rate, right? This is proportional. Because this is exponential, I'm not adding, I'm multiplying or dividing. So 1.5 divided by 3 is what? No. You could multiply by 2. You could double it. From 3 to 6, what do you do? Times 2. And from 6 to 12, what do you do? If you went the division route, you'd still get the same pattern. It'd be a different value. 1.5 divided by 3 is 0.5. 3 divided by 6 is 0.5. 6 divided by 12 is 0.5. So it's constant. So is this guy an exponential function? Yes. Is this one up here an exponential function? No. Because it's exponential, you want it to be a constant multiplication or division change. And last but not least, let's squeeze in our notes right over here for graphing. To graph an exponential function, you've already done this tens of times. You choose an x value or x values to substitute. On your homework, they're going to give you the numbers, but if you're asked, I think it's easiest to do -2, 0, and 1. If they ask you for 4 numbers, you throw in a different number. You could do -1. I just like to do -2, 0, and 1 because they all have a different absolute value, so it gives me a better sampling. You could do -1, 0, and 1, but -1 and +1 would have the same absolute value, so it's not going to give you as good of a mixture of data. But you just pick some numbers. Don't pick 7, because you're picking the number that goes in for the exponent. And you saw what happened when we picked 5, we got to 486. Right? You don't want to pick numbers outside of this range very often. This is no longer going to be a parabola. It's a different type of graph. So you choose x values to substitute, then you graph the ordered pairs. So if you substituted -2 and you get an answer of 40, your ordered pair is -2, 40. Yeah. And then you just connect the dots. Ladies and gentlemen, you're going to have to still curve your line. It's not going to be straight. This is a non-linear graph. You're going to have to be a little artistic.